Okay, this is Math 30-2, Midterm Review, Unit 1, Logs. So we're taking a look at the very first specific outcome. This is relations and functions. The first one says we want to demonstrate an understanding of what the laws of logs mean. So the first one is all about log laws, okay? So if you'd like to take a look at the ones you have here, these are basically almost going in order, okay, right here. So the first one says express a log equation as an exponential and vice versa. Okay, so this is the very first one, the second bullet you guys see on yours. So 4.1 here, a good example of something like that would be, even if we try ln, you always have to remember we have to do ln questions. So if we do 5 to the x equals 4, and we want to change that to a log form, we have to always write the word log first. We drop the base down to where the base goes, down by the g, and then the x and the 4 trade places. So 4 equals x. Okay, so it's just a big switcheroo there. So this guy drops down, and the 4 and the x trade places. And then if you've got that log base button in your calculator, that's what you would type in. You type in log base 5 of 4. Okay? If you don't, then you've got to type it in using the change of base method. So the way you would type it in, you would type in log 4, divide by log 5, and then enter. And remember to close brackets. Log will automatically open a bracket on some calculators, and if it does, make sure you close the bracket right after the digit. Okay, so brackets are necessary, especially if your calculator automatically throws them in there for you. Okay, so that's one example of switching exponential to log, and we can go vice versa. We're now going to do a base E question, because base E is also with ln and log. Okay, so this guy had a digit as a base. If we have a digit as a base, we are always using log form. If we have a base of a letter E, then we're actually not going to use the word log, we're going to use the word ln. So if I've got, second example here, if I've got e to the 5x, well actually I'll just say x for now, e to the x equals 12. Okay, e to the x equals 12. Well, again, we're going to do the exact same thing here. The base, the way the base, the 5 here dropped down on the word log, we're first going to write the word ln. The letter E drops down, which it automatically opens with the letter E. Then you've got E exponent x. Now, why is it E exponent x? It's because the word ln automatically has a base E right there. So this is just dropping down. So what you're getting is the x and the 12 have to switch places. Again, just like the 4 and the x above. So we're going to have ln, the base E. Like I said, though, the E can hide. You don't have to actually write it if you don't want to, because it hides. It's like base 10 with the word log. So now you're going to have 12 equals x. So it's just ln 12. Okay? The E, if you want to write it, it's not wrong. So you could write ln E12 equals x. That is also correct. Okay? Now, let's say we've got one written in ln, and we want to change it back to base E. So let's say you've got ln 45, and you want to change it back to exponential. So the base on ln is always a hiding E. So in order to get rid of that, we're going to base E both sides. So basically, these guys switch places, and the word ln disappears. So we're going to have E exponent x equals 45, and ln E will disappear. Okay? Because the word ln is going to disappear just like log disappears. Okay? the base there, sorry, the e would stay because the e's going down. Here's your base. Okay, let's go back and forth now from a log to an exponential. We do log. Let's say we've got, example 3, let's say we've got log base w of q equals m. Okay, and I want that put in exponential form. How would you put this in exponential form? To go to exponential form, what is the first rule you're going to do? Automatically, you have to do it in order to switch to log or exponential. No, you're really close though. You switch the q and the m, and then something has to disappear. The log, good. So we have to actually get rid of the word log, it's going to drop off, and then these guys switch places. Okay? So in exponential form, it's going to be w to the m equals q. Okay? That's switching forms. Now we're going to go to same base solving, which is one of our log laws. Okay? So, same base solve. This is on one of your exponentials. This is going down into the second and third bullets. So, if we've got example, log base 5 of 625 equals x. These are ones where if you're able to take it into exponential form right away, if you understand same base, then definitely try that. So what we would do is we would see if 625 can go to a base 5. It does. So we would change 625 to a base 5. So we're going to have log base 5. That part doesn't change. The part that changes is this. He becomes 5 exponent 4. All equaling x still. And now there is a log law rule that states if the argument and the base have the same base, then the answer is the exponent on the argument. So that means these guys cancel basically, and x is equal to the exponent. Okay? This is true, and this is why it states that log of x of 1 is equal to 0. It's to prove this as well, that anything exponent 0 is equal to 1. Because if I do this, log base x of x to the 1, this here is not x to the 1. You can't cancel them the same. Okay? So for one of these, you cannot use that rule if the base is not a same base here as your argument. This is a digit, that's a variable. They are not same base. But they're trying to prove this law, stating if you go to exponential form and you do the 7 rule, basically get rid of the word log and switch these guys, you get x exponent 0 equals 1. The base can be absolutely anything. And anything exponent 0 is 1. Okay? That's why anything with a log base, a log argument of 1 will always give an answer of 0. And that's also another base log law. Okay? That we have to know. Okay? Alright, so we've got a couple log laws. We're going next into the adding, subtracting, multiplying, and dividing. So, the next log laws, we've got adding ones. We've got log 5 plus log 7. In order to combine those into one log, if there's a plus sign between them, you multiply the arguments. So these guys are going to multiply. And that's how you combine them into one log. So if it ever says simplify to one log, that's what they're asking you to do. So it's just log 35. And then they would ask you to solve that, because you can't. You type in log 35, enter. Okay? So that's your base log law when you're adding. If they are separated by an addition sign, that means you're multiplying the arguments. Now we're going to do the exact opposite. If I've got log of 216 minusing log 6, the question is actually asking me to take 216 and divide it by 6. You're always dividing by the number on the right-hand side. So the number to the right of the subtract sign. So it basically becomes a fraction in your calculator. The number on the left goes first on top, 216 divided by 6. Okay? This is going to end up giving you log 36. And then you can type that in, hit enter, and it'll solve for you. Okay? Any questions on the two basic log laws? Pretty good? Okay. Now we're going to jump into when we've got exponents attached. Okay, so what happens if there's something hanging out in front of the log? So, here's number 3. If we've got, let's go with 6 log base 2 of, I'll just say log 2 of log 2. There we go, let's just try basically. So, in order to combine this or solve this, there's a couple ways. They want you to do it exponentially or solve it algebraically. They're asking you to literally take the 6 and use it as an exponent on the 2. That's what it's asking you to do. You're not multiplying them, you're using it as an exponent. So you're going log 2 exponent 6. Okay? So this is going to give us log 64, and you would type that in, hit enter, and you're good to go. Okay? So when there's something out front, and they want you to simplify, you need to bring it up top. Okay? Now we're going to put all this together into a couple big ones. Okay? We're going to challenge our brains here. Where's my thing? Okay, so let's take a look at some of these laws and put them together. So, we're going to have 4 log base 2 of 3 minus log base 2 of 9. Let's just go with that one first. We'll stop there. We'll just do a small one here before I start throwing some bigger ones. Okay, so what's the first thing you have to do? Yeah, you have to move the 4. You can't combine them until you move the 4. So we're going to move the 4 up on the 3. And that means it's going to become an exponent. So now you've got log base 2 of 3 to the 4th power minus log base 2 of 9. So now, 3 to the 4th is 81. So we've got log base 2 of 81 minus log base 2 of 9. So now what do we have to do? Divide them, okay, because there's a subtract sign here. So now we're going to take 81 divided by 9, we get 9. So we're going to get log base 2 of 9, and that's what we have to type in. And again, remember, depending on what your calculator says, you type in not log 9 divided by log 2, depending on what if you have that log base button or not, because some of you have to do it by that change of base.
What do you do when the bases are different?
Okay, when bases are different, you can't use log laws at all. Nope. And you can only combine the ones with the same bases together. They won't throw a big one with you with multiple different bases because they're going to ask you to simplify them. So let's try a few with some variables. So if we've got 1/2 log base x of w plus log base x of, let's go with y squared minus log 4 log base x of z. Okay, variables can get a little tricky. So whenever they use a variable and you can't solve right away, what you need to do is write the log and the variable base with a big set of brackets. So that's our very first step. Log, big brackets, put my base in, my base is x. Okay, that's my very first step, and I create a fraction. The reason I create a fraction is because I see a plus sign and a subtract sign. If I have a plus sign and a subtract sign, that means I'm going to be multiplying some things and I'm going to be dividing some things. And when we have variables and we divide, we have to create fractions because we can't divide variables otherwise. Okay? So, the 1/2 has to go up on the w. So we're going to have w exponent 1/2. He always goes first and he will always go on the top left. Okay? So the guy that is written first will go top left always. So w exponent 1/2. Okay? Now exponent 1/2 is also square root. It means square root. So you could write square root w there if you want. You don't have to, but you could if you wanted to. The next one, the exponent's already up on him. He's being joined by a plus sign, so that means he's going to go on top. Being multiplied means sitting beside the other guy. So y is going to sit on top beside the w. The guy being subtracted is going to sit on the bottom, but he's got to take his 4 up on his exponent first. So z's going to the bottom because he's being subtracted. Z exponent 4. And that's as far as we can go. We can't go any further with that. And there is a question similar to this on your midterm. Okay? Very similar. Where you have to know where they go. Do they go on the top, the bottom? Who goes first? Okay, where do the brackets go? Do you need brackets? If there's variables, you need brackets. Okay? So if there's no brackets in the questions and it's multiple choice, don't even look at the ones without brackets. If you've got plus and subtract stuff with a whole bunch of variables, you need brackets in this form. Okay? So that's a little trick there. You just kind of think of that. Okay, so we've gone through all those. The next thing we're going to do is we're going to start solving with non-same base. Okay? Sorry, we have to solve the same base first. So, if we've got 2 exponent x equals 2 to the 5, just 2 to the 5. Let's go like that. So, when the bases are identical, you remove the bases, you just drop them. So, that means we're saying x equals 5, period. Okay, that's supposed to be an equal sign. Not half a case. So, same base, drop the base, solve for x. That was a simple little guy, so let's take one of these. Let's go with 3 exponent 2x minus 1 equals 9 to the, let's go 9 squared. All right. So what is the first thing we're going to have to do on the right-hand side there? That's right, take the 9 to a base 3. So this guy's already base 3, he comes down 2x minus 1. This guy goes to base 3, 3 squared, but he already has an exponent. So that exponent's going to join up with him, but he's going to go in a bracket. Okay, so that means when they're joined beside by a bracket, that means they're multiplying. So this now becomes a 4. So we've got 3 to the 2x minus 1 equals 3 exponent 4. Now we need to get rid of our bases because we have same base. We can drop them. We get 2x minus 1 equals 4. We now need to move our 1 to the other side, so we want to isolate the variable. Get x by itself. We add 1. 2x equals 5. Divide out the 2. X equals 2.5. Beautiful numeric response question. Okay? Remembering the numeric response questions are always positive answers. So if you get a negative answer, try the question again. Okay? All right. So we've gone through the first step. Now we're going to take a look at how do you change forms and convert and save non-same base, solve non-same base. So, solve non-same base. I don't know why they just don't call it solve different bases, but they say non-same base. Okay, so if we look at that outcome, we have an example like this. Whoa, what's going on here? Okay, go away. Go away. Go away. Okay, I don't know why it was coming up there. Okay, so 3 to the x plus 2 equals 7. The minute we see a question where the bases cannot be put into the same base, 7 will not reduce to a base 3. So that means we're going to have to convert to log form. And it's easy if x is only on one side. Okay? Here we only have an exponent of x on one side. On the right-hand side, no exponent. This is a simple switch, write the word log. Okay? So this is convert to log. Okay? Convert to log form. The minute you see different bases, that's what you're going to do. So, the word log has to be written. The base will be dropped way down low. He goes there. And now these two switch places. So now the 7 goes inside. And on the outside of the equal sign, you're going to have x plus 2. Now the question isn't solved yet because you want to solve for x. So you could type this part in and then subtract 2 because you've got to get rid of this 2 to put it to put it to the other side. So to get rid of it, you need to subtract 2 here. You would subtract 2 from this final answer. Okay? If you wanted to put it all in one step, you would write -2 plus log base 3 of 7. That's how you would type it in. Okay? Or solve this first and then add -2 or subtract 2. Okay? So that's how you solve those ones when x is only on one side. Okay? The minute we have x on both sides, that is increasing the difficulty level. Okay? So that changes to a hard. The minute they put x and digits, so x and constants on both sides, that changes it to a standard of excellence. So let's take a look at a couple more. So if we've got 2 to the 5x minus 3 equals 5 to the x. This one, whenever you've got x on both sides, this is a straight up calculator. We don't solve these otherwise. This would go into your y1, this would go into your y2. And this is, like I said, a standard of excellence question. The minute they throw a variable on the other side, right? Even without a constant, it is considered standard of excellence. Because at our level, all that we want to be able to do is switch to log form. If you can switch to log form with x on one side, you're laughing. Okay, that's the hardest they really get. These ones, you go instantly to your calculator. Now, because there's more than one thing here, he's a binomial, you have to put this guy in brackets in your calculator. So in your calculator, you would have 2 exponent that in brackets. This guy, you would just have 5 exponent x. And they're going to be in your calculator, and they're going to come out like this, and you want where they intersect. That's what you actually want, okay? And you want the x number of where they intersect. Okay? That's how you do these questions if there's x on both sides. Okay? The next thing we have is just identifying and being able to match exponential to an exponential graph. Match a log to a log graph. And what are their characteristics? After we look at those, then literally all we have to be able to do is look at a couple problem solving questions for unit 1. So, next thing we jump into is did I just say? Problem solving questions. What was before that? Either log laws. It is, it's pH. So pH, earthquakes, and decibels. I didn't put any decibels on there this time. So these guys are always on a premise of this is equal to 10 exponent magnitude 1 minus magnitude 2. This over here might be written as a fraction. All they're showing you this fraction for, this fraction means this. That's what they're showing you. The intensity of the first one is being divided by the intensity of the original. And this guy right here, that's why they're showing subtraction, because they're subtracting exponents when you divide same base. Okay, that's what this is showing you. You don't need to know anything for here. This will always be a digit. It'll be a digit or a fraction. And they're either going to be asking you to solve it, where you're going to say you'll have one earthquake. Let's say there was an earthquake with a 4.2, and you had another earthquake that was 75 times stronger than that guy. Well, then the 75 is here, X is here. Okay? Because you're looking for a bigger earthquake than this guy. Okay? Now, most of the questions you guys get, and again, what would you do with this question? You'd base 10 it to solve it, and solve it with logs. Okay? Or throw it in your calculator. Y1, Y2, boom. Okay? You get the intersect, same thing. You can solve it two different ways. Okay? Do you want to solve a question like this? Okay. So, let's solve it. Let's just switch to log form. Okay? So, log uses base 10, right? So, we're going to have log, which we're dropping our base 10 down. We're switching this with the 75, right? We're switching it with this side. Okay, so now the 75 goes here, equals x minus 4.2. All we've got to do now is move the 4.2 to the left. So now we're going to get, move this guy over here, plus 4.2. I would type in 4.2 plus log 75. Enter. And then we're done. Okay? This question is set up to look funny to you, but all you're doing is literally switching it to log form. That's it. Okay? It's just a switcheroo.
And how, again, how do you know if X goes what?
Okay? There's a couple different ways. If it's multiple choice, and the question is saying that you're looking for a stronger earthquake, and this guy's a weaker earthquake, less intense, then X will be first. If you're looking for, if they're saying that you have a 9.5 earthquake, and I don't know, maybe it's 10 times stronger than another one. They'd put the 10 or the 75 like that here, and then you'd look for the X way on the end. Okay? We'll do a couple questions. There's some coming up, okay, in the problem solving. Okay, so this is just a complete switcheroo. I want to do another one just set up like this though, okay? So let's say we've got magnitude of a 6.5, and it is being compared to a magnitude 3.1. So magnitude 3.1, and it wants to know who is stronger, or how much is this guy stronger, how much more strong is he, how much more intense they would call it. So what is the intensity of this guy compared to that, basically? So you're just going to literally say intensity equals 10 exponent, the big one subtract the small one, and you type it in. So you would literally subtract those, and then type in 10 exponent that number. Okay, and that's how much more intense or strong that earthquake was. Okay, most of the ones you guys get are these kinds, and if the other ones, and if they give you another number here, let's say they give you one where it's 225 times more intense is this one earthquake than another, and you want to find out how much the weaker earthquake is. So you would have 10 exponent 7.5 minus x. Okay, so the weaker one always goes to the right. Okay, stronger one's always on the left. And if they're telling you you're comparing to a stronger to a weaker, you're weaker you're looking for. okay? And again, you just switch this to log form. Do you want me to help switch that one again? Let's switch this one, okay? So, when we switch to a log, let's just go back to a normal log. So or a normal base. So let's say I had 5 equals 7 exponent x. Okay, just a basic one. The base stays the base, same as the 10. The base stays the base. These guys switch places. And you write the word log. Well, these guys here, these are going to switch places. And you have to write the word log. Okay, base 10 stays base 10. Okay, so you're using the same concept. So, let's do the switcheroo. We write the word log. It is a base 10. It's going to take 225 equals 7.5 minus x. Okay, you don't have to show the 10 down here if you don't want to, because the 10 will automatically hide, just like the letter E on log hides. Okay. So those guys switch places, that's all that happened there, and you wrote the word log. Now we would type in log 225, we would bring this guy over, and then we would divide out the -1 in front of x. Because you always have to have a positive 1 in front of x, not a -1. And right now that's showing a -1 in front of x. Okay? Does that make sense? So we would subtract this number over here, subtract it over here, connect with a plus sign, and then divide the whole thing by the -1, okay, to get rid of that negative in front of x. All right, so that's how we solve our log equations. Now let's take a look at pH. pH is going to be done the same way. You're going to compare alkalinity to acidity. But all you're doing again is base 10. So if we talk pH, they're going to show you an equation that says pH equals negative log x. And x is the number of hydrogen ions. 99% of the time, they're going to give you this and they want you to find that. Well, if they want you to find the pH, all you're literally doing is typing in negative log that number. Okay? Now, if it's a multiple choice question and they're looking for the pH, literally all you type in is negative log this number and see what you get for an answer. And the pH number should be in the multiple choice answers. Okay, there's ways to get the questions to help you answer them. Okay, so those are basic pHs. Now, again, it could say, well, something is stronger, more acidic, or basic. So I'm just going to put A/B on acidic or basic or alkalinity is equal to 10 exponent pH1 minus pH2. So it's very similar to the magnitude earthquake one. Okay, and they'll give you this in the equation. They'll show you something similar to this. And this is all you're doing. Okay, you're just subtracting the pHs and then writing 10 exponent that number. Okay, that's how you find how more alkaline or how acidic it is. And again, that's going to depend on where you put your digits. If they're asking about alkalinity or if they're asking about acidity and who they're comparing. It's very, very specific in the questions though. Okay. All right, so now we have to take a look at doubling time and the basic equations and what their graphs look like. So now we're talking about basic, exponential functions and their graphs. And we're going to compare them to the logarithmic ones. So our basic exponentials, they use quadrants 1 and 2. They're going to go up or they're going to go down. Up meaning from quadrant 2 to 1. They're going to rise. They're going to fall from 2 to 1. So it's always 2 to 1, 2 to 1. Now, the equation looks like this. Y equals A times B exponent X. That equation gets varied. So sometimes they can use X as an exponent, as a fraction. B cannot be a fraction or a decimal, so can A. But they're often going to show you these parameters. A greater than 0, B greater than 1 or greater than 0. If they're showing you actual parameters and they're saying match it to a graph, put in your y equals and throw some numbers in there. So what I would do is I would say, okay, well, in my y equals in my calculator, If A has to be bigger than 0, well, maybe I'll put 2 in there. And if B has to be bigger than a 1, well, maybe I'll put a 3 in there. And then an X. Just try putting the numbers where they're being described. And then just graph it and see what it looks like. Okay? Because this is the basics of what we know. They're going to throw questions at you where they change these parameters. We always know we deal with quadrants 2 to 1. But if they reverse it and flip it down here, which they can, if they say A is less than 0. Okay? So if they say A is less than 0, you're immediately doing a reflection down in quadrants 3 and 4. Okay? So you have to think of that as well. And again, all you do is put in numbers. So if they told me, my next example, so if they told me A was less than 0 but B was bigger than 1, I would put in numbers like that. So I would maybe put -2, 3 to the x. Okay? So make sure you're putting numbers and look at the graph. See what it actually does. Most of this exam you can do on your calculator and match it to your graph. Match it to the information they're giving you. Okay? Any questions so far? No? These parameters really matter. You have to understand what they're doing. Now, B being bigger than 1, B is the one that controls whether the graph rises or whether the graph falls. So, there's also questions where they won't show you an A value, where they're going to see this. Here's one up here, here's one up here, here's graph, let's call this graph Q, and this graph M. And we're going to say that graph Q is y equals b to the x. Well, if this is y equals b to the x, where's the a? It's 1. They will always have an a value. If they don't tell you an a value, your a value is automatically +1. So that tells you right here on the scale, that's +1 that it's touching. Because the a value is the y-intercept. And you have to know that part. So the a value is the y-intercept. The b value controls rise or fall. So whether it's going to increase or decrease. Okay, increase and decrease is what they control. So, if a question says, what could the y-intercept of this guy be? What's a logical y-intercept of that one? If this is +1, and I know that this down here is 0, then what is in between those? 0.5, or maybe 0.75, whatever, however it is on the scale. But here, I would probably roughly say that's a 0.5. It's halfway. Okay, so you have to understand they're just showing you one of them. They're giving you lots of information. So graph it, plot the information you know about it, and then read what the question's asking you. Okay, so this is an old diploma question where they ask you things like this. Okay, now what if they tell you you've got B is between 0 and 1? So the way they do that is this. They're going to say 0, B, 1. That's what they say is 0 is between 0 and 1. This is a decrease. Okay, so those graphs are always going down. Okay, that's what controls these ones. These ones are always going down. Okay. All right. Now we're going to look at doubling time and half-life. Okay, and the exponential fraction equation. Okay, everybody's favorite, I know. It's all about putting it in the calculator properly, actually. It's all about brackets. Brackets matter. Okay. So, half-life. Well, all they've done is they've taken this equation, y equals a times b to the x, and they've made the x now a fraction. So now they've got this, a times b to the t over p. And the p stands for period of change, rate of change. And what that states is how often the B is happening. Okay, the P tells you it controls the B number. So it's the period of change. Okay, whereas B is often known as the rate of change. Okay, because it controls the increase and decrease. So if they're telling you something is tripling every 7 hours, so if I were to write that example, example 1 triples every 7 hours, what I'm going to write is y equals a tripling exponent x over 7. That's what I know about that equation. This is the B number, okay? There's the B number. B is the tripling. It'll be the triple, the double, the half-life. Okay? If something doubles, half-life, that number will be there. The 7 is the one that's controlling this guy. It tells you how often it's happening. So this guy's tripling every 7 hours. There's been a question on the diploma where it says, what is the doubling time? And literally all it wanted to know is if you knew which number that was in the actual equation, what it represented. Okay, because these can be difficult equations. You have to understand what each variable matters or means. Okay? The x on top normally is a t. I changed it to an x because I like x. But the t there, the x, that stands for the time period that you're in the lab doing this experiment and measuring the time frame over. Okay? So this is the time measured over. Okay, that's your actual time that you measured. Okay? In an experiment, let's say. So if you only did it for 30 days, and this is happening every 7 hours, that's a lot. You're going to have a lot of data. But maybe you only did 2 days. If you did 2 days, well, that's your time on top. But if this is in hours on the bottom, you would change your days to hours. Your time frame has to be the same. All right. That's the basics of these. Okay? Now we're going to take one more change they did to that equation. They made it into an interest equation where we've got the depreciation for vehicles and where we've got increasing and gaining money. Okay, so investments. So that's our next one. So again, what they've done, this is investments and depreciation. And this is the last thing for this, second last thing I should say. So they again take this equation, y equals a times b to the x. They take that equation and they change the b and they make it into 1 plus or minus the interest rate. So I is always a decimal. And it's the interest divided by 100. Because they'll tell you the interest rate. So it's the interest rate divided by 100. That's what that I number is. Okay? So they change this whole B part. And that's what they make B become. You would use the plus sign if it's an investment or you're saving money. Okay? Then you use the plus. Depreciation, we'll use the minus. And I'll show you what the equations look like. A lot of the questions they do are just matching the information to the equation. Do you know which one would match the situation? Okay? A lot of them aren't even solving anything. It's just matching information. Okay? Triple hint, that's what lots of questions like. Okay? All right. They changed the A to a P. P meaning principal amount of money. And that's what they used it for. Okay? That's your starting amount. Again, where do we start on an exponential equation? On the y-axis. It's your y-intercept still, but they call it the principal amount. So it's your starting amount. That's why they use the letter P for principal. Your principal amount. LE. Principal amount, I think. So, the Y, they just changed to A, and A means the accumulated amount of money. Okay, what have you accumulated? The X, they changed to N, the letter N, and all that means is the number of years. N stands for time in years. They will give you all this information. They will never give you the equation without telling you what each part means. Okay? They've got to let you know. So, let's jump into a couple equations. Okay. So, if I've got example 1, we're going to say it's an investment of $5,000 at 2.4% per annum, and this is going to be annually, compounded annually. Now, you always look at that word compounded. You have to see what the word after it is. 99% of the time for you guys, they'll give you annual. Standard of excellence means you have to understand the difference of what monthly and quarterly would be. So if they said quarterly, what are they telling you to do to the equation? If they said monthly, what are they telling you to do to the equation? They want you to understand the concepts, but they actually don't test you on that on the actual diploma. They'll always use annual, which is good. You don't have to divide I, you don't have to times N, your answer is your answer. Okay? So we would start like this. A equals, what's my starting amount? What money did I put in the bank? $5,000. So I'm going to put 5,000. Now I open up my bracket for my B value. Now is it going to be 1 plus or 1 minus? Plus. It's going to be a plus because we're investing. We're making money, okay? If we're losing money, it's going to be a bigger interest than 2.4%. The interest will be over 10% if it's depreciating. So whenever it's losing money, you're losing over 10%. It's a big number, okay? Whenever you're growing money, it's a small number. They never give you a lot of money. They're going to give you a tiny interest rate. That's logical, okay? So I have to take 2.4 and I have to divide it by 100 because I want it out of the percentage. So that's going to give me 0.024. So that number goes here. 0.024, close my bracket, and then I put X or N, whatever I want. Now, if they said, when will it reach $10,000 or when will it double? Sometimes they'll say double and not tell you where that number goes. Well, if they're saying doubling, that's a money number, that's your A, accumulated amount. If they're asking for time, how long did something take? They're asking for the X, the end. Okay, they're asking for time. So, if they give you a question like that, say, when will it double? A couple different ways to do the question. If it's multiple choice, I would literally type this in, exponent, answer for A, answer for B, answer for C, answer for D, and see which one gives me the answer. That's one of the quicker ways to do questions. Okay, let the actual multiple choice answers guide you. Okay? Now, if you can't do that, it's a numeric response. What you would do is you would put this into Y1, this into Y2, let them crisscross, and find the intersection. Okay? Or you can solve it with logs. Do you want to solve this with logs? Okay? So, first thing we would do is divide this guy out. We divide out 5,000. Divide out 5,000. I end up with 2,000 equals 1.024 exponent x. Now it's literally a log conversion. This guy and this guy trade places, and I write the word log. The base drops down when I write the word log. So I'm going to have log 1.024 of 2,000 equals x. So they're not that difficult to switch to log form. All you've got to do is divide up that first number. Okay? Any questions so far? We've now completed all of Unit 1. The last thing we do for all of Unit 1 and all of Unit 3, we just don't do in Unit 2, is regressions. So I'll look at regressions right now, and then we won't have to look at them later. So, regressions. That's when it's going to give you a table of values, either horizontally, X and Y, or it's going to give you vertically, X and Y. You put them in your lists. List 1, list 2, list 1, list 2, and you do your graphing basics on it. So you do your stat, calc. If it's exponential, do a 0. If it's logarithmic, it'll tell you which one it is. There's 3 regressions I put on there. There's a cubic for sure, I know for sure. I think there's a sinusoidal. There might be a log or exponential. So there's 3 of them for sure I know I put on there. Okay, so make sure you're putting your information in. If you forget, yes, it's there. But do practice. Hopefully most of you already know the steps because you've been doing them. Okay, so that's it for Unit 1. Logs. Any questions on logs? No? Okay, let's jump into Unit 2 and tackle rationals real quick. Okay? So, Unit 2 rationals. Big up comes here. Click. SO1. We need to be able to do equivalent forms. So simplify and do equivalent forms. So simplify and equivalent forms. So, an example of that would be, you've got 4x cubed plus 12x over 4x squared. And you've got choices. X plus 3, squared plus 3x, x plus 3 over x, d 4x plus 3 over x. Okay. So we need to be able to simplify and do equivalent forms. Again, equivalent forms basically means simplifying. Being able to reduce it, meaning divide it by the same thing, or multiply it by the same thing. So this one wants us to reduce it. So what number could I divide out of all 3 digits? A 4. So we could take a 4 out of everything. If I reduce everything by a 4, he becomes a 1, he becomes a 3, he becomes a 1. All right. How many x's may I remove? Only 1. So this guy would go, he becomes a 1, he becomes a 2. So I would get x squared plus 3 all over x. Okay, so we did find our answer. Where is it? Oh, this guy here is supposed to have squared on him. Am I supposed to be this guy? He's supposed to have squared side on him. Yep.
If you take away an x from the x cubed, then you just completely erase all the x's on the bottom?
No, because you have to be able to take the same amount from each on the top as the bottom. So if there's only 1 on top on this one right here, I can't remove 2 from everything. I can only take out the least amount. Okay? And if this guy here didn't have an x, I couldn't remove x from any of them. Okay? That's just part of simplifying. All right, let's take a look at another one. So, basic simplifying. Then we get into our multiplying and our dividing. Okay? Now, do we actually divide? No, we flip and times. So dividing means flip and times. So, we have questions such as, x over x minus 3 over 5x squared times 25x over x cubed and 3 minus x. a good one. It's got that reverse. Okay, so we see a multiply sign between them. First thing we check and see is if everything is factored. I see some brackets, lovely. It looks like it's factored. Yes, it is. But if you look in the brackets, do the brackets match? Brackets don't match, they're backwards. So that means I need to take a negative sign out of one of them so that they will reverse and look the same. So I'm just going to take one out of the top because the negative sign will float to the top anyways. So I'm going to have negative x, 3 minus x, over 5x squared times 25x over x cubed times 3 minus x. So now we've got her down to what they look like identical, okay? You could have taken the negative and put it with the 25 and reversed the x and the 3 on the right-hand side if you wanted. It'll all end up the same in the end. So now we're going to have to find our non-permissible values. How do we find non-permissible values?
Bottom.
Yeah, it's from the denominators only, okay, when we're multiplying. So we look and see what would the denominator equal to 0. Yeah, Dylan?
Do you not take a 5x?
Yep, we're going to do that. But we have to make sure that after we factor, then we do non-permissibles. Okay? So at this point, we're at the NPVs. So factor, then NPVs. So we look at the bottom left. 5 times what would make this guy 0? 0. So one of them, x can't be 0. Okay? X cubed, if he's sitting beside a bracket, any variable sitting beside a bracket is always 0 again. 3 subtract what is 0? 3, positive 3, good. So 0 and 3 are the non-permissibles. Okay? So now we can start reducing them. So I can instantly take off the x minus 3 because I know they're identical. We take those off. Now I take a look at my 25 and my 5 can reduce. We both divide by 5. And now I can look at how many x's I have on the top and how many x's I have on the bottom. I've got 1, 2 x's on top, and over here on the left I've got 2 x's. So I'm just going to cross those guys out. And now on top, the only thing I have left over, and it's a good idea to highlight them so you don't forget them, I've got a 5 and a negative. So that's all I have left on top. On the bottom, I've got x cubed. That is all that's left over. So my final answer will be negative 5 over x cubed. Okay? So a lot of times, you won't even have a denominator sometimes. Okay? Sometimes it'll reduce right off. Okay.
How do you get the
Okay, dividing. Let's take a dividing example. Let's go with 15x squared plus 5x all over x cubed minus x squared divided by 2, 1 plus 3x all over x plus 1. All right. So half is factored, half is not. And we have to be able to flip n times. So the first thing we need to do is factor the left-hand side. Okay, that's our very first step. So, what can we remove from the top left hand? A 5x, good. So we can divide 5x out. 15 divided by 5 leaves us 3x left over. What's 5 divided by 5? 1, good. Plus 1. All right, we got the top factor. What can I remove from both of those? Yes, there are 2 x's, x squared. Okay, on the bottom left. So that leaves us an x and a minus 1. Oh, it's a plus, pardon me. It's a plus 1. Change it, please, it's a plus 1. It is a plus 1. Okay, so now I need to flip it, the guy on the right-hand side. Okay, we need to flip the guy that's flipping and timesing. So now the divide sign changes to a multiply sign. And now I've got my left-hand side, my right-hand side.
You will always flip that second set when you're
Always when you're dividing, yeah, you betcha. You betcha. And now we start looking at what we can match to remove. So what can we match that we can remove? Well, what step did I just forget? NPVs, yes. Okay, NPVs. And now when we divide it, dividing's a little bit different. Because we have to flip the guy on the right, we have to take the top and the bottom of the right-hand one. Okay? So what would make the top right equal to 0? 0 and -1. Okay. What about on the bottom? Pardon me, -1/3. Okay? So this guy here makes -1/3. Take the digit by itself out, opposite sign, the number in front of x goes to the bottom. So this guy's -1/3. Okay, what's this guy over here? -1, 0. Okay, you already have those guys. So we've got our non-permissibles. Now we start crossing stuff off. So I can cross off my x plus 1. I can cross off the 3x plus 1. It's written backwards, but that's okay because the signs still match. They're both still positive, so that's okay. So we can take this guy with this guy. Now we have to look and count the amount of x's we have on top and bottom. How many x's do we have on the top? 2. How many do we have on the bottom? 2, so they can go away. Because x1, that makes x2, and the x2 down here goes away. Perfect. What do I have left over? 5/2. It's actually a digit. Okay, so the answer for this guy would be 2.5. And then we would say, is that a possible answer? It's not a non-permissible, so yeah, it's a possible answer. Okay? Any questions with multiplying and dividing?
Since it was originally dividing, then you did the NPVs for all of them.
For all at the top left, yeah.
Because it's what
Mm-hmm. Yep, you bet. All right. So now we are plussing and subtracting. So we're going to add and subtract, then we've got to put an equal sign in. Add and subtract. So, let's take a look at 4x over 2x plus 5 plus 10 over 2x plus 5. So here's the first question. What do you notice about the denominators already? They're identical. If they're identical, you just add the top. Well, the top, they're different. Okay, one has a variable, one doesn't, so they're just going to slide beside each other. So we're going to have 4x plus 10 over the denominator that we only have to write once now. And now we factor the top to see if we can reduce anything. So what can I divide out of that top? A 2. And now what do you notice? They're identical, so you can cancel. So the answer for this guy would be 2. Okay, we would cancel that. Now, we do have to do non-permissible values on this. Yeah.
The reason you don't have to do everything has to take out a 2 from everything is because it started out as an adding? Or
No, we're just literally reducing the top. Like I'm just factoring it.
Okay.
So all I did was factor this. I didn't reduce it. I factored it. By taking a 2 out, I factored it.
So isn't that simplifying?
Factor helps simplify,
So,
yes.
Then why do we sometimes have to take it out of the bottom as well as the top? Like for the simplifying,
Yeah.
we did a question and it was 4x cubed plus 12x
Right.
and we
Because-
took it all.
Right, it was because that was a question where it said find the equivalent form, or it said just simplify. If you're just simplifying, it has to come from that monomial. Okay? We created a binomial, so that is a bit different. Alrighty, so our answer here would be 2. So that's our adding and subtracting. Let's take a look at what if we have a subtract sign in there, and nothing is factored. So here's our example. 1 over x squared plus 7x minus 2 over 49 minus x squared. Whoa. So we're going to have a switcheroo thing going on here. So let's factor the left first. So I'm going to have x and x, see x plus 7. Now, what are you noticing about the guy on the bottom right? It's a difference of squares, but they're written backwards. I need the x first. So that means I'm going to have to divide out a negative sign. If I divide out a negative, that puts a negative there. And what do we know with two negatives in the middle? They become positive, yeah. So now this becomes positive, and now this becomes x squared minus 49. And now I can factor that, because it is a difference of squares. So you're going to square root and square root. So I've got 1 over x plus 7, plus 2 over x plus 7, x minus 7. And now when we are looking at adding and subtracting, we have to look at common denominators. The other question already had a common denominator, so we didn't need to change anything. This one, you always have to factor first, then do your common denominator. But we've got to find our non-permissible first. What would the non-permissibles be for this question? Plus or minus 7, and on the far left, 0. So NPVs, plus or minus 7 and 0. Okay. Now, what would our common denominator be? We have 3 separate things. When we have 3 separate things, we need to use all 3 of them. So the guy on the right is missing just the variable x. And the guy on the left is missing the bracket x minus 7. So that's what we have to do. Our common denominator is going to be this. X plus 7, and this guy needs an x, this guy needs an x minus 7. So, it's going to end up being a little bit messy, but that's okay. So an x minus 7, and this guy needs x, with x plus 7. So, what we have to do is we have to add to the top what they're missing. Just going to rewrite this guy. End up being here. X. Now we're going to multiply to the top what they are missing. So what is the guy missing on the left? The x minus 7 that I put in blue. So what's 1 times x minus 7? Just x minus 7. So he goes up there. Okay? Now on the right hand side, what are we missing? Just x. So I'm going to put an x beside the 2. So he's 2x. So now I've got to add everything on the top. I've got a 2x and a 1x. That's going to give me 3 x's. So I'm going to have 3 x's subtract 7 on top. So this is going to become 3x minus 7, all on top of x plus 7, x minus 7. And that's our final answer. We can't go any further. Okay, you're going to get an expression as an answer. Any questions so far on that? Yep. That's when we put an equal sign. So that's our very last thing we're going to look at right now. Okay? So after adding and subtracting comes solving equations. So we have to simplify them, we have to multiply and divide them, we have to add, subtract them. Now I'm putting an equal sign on. When we do an equal sign, they're in the adding and subtracting stage. So we have to do a common denominator. Once we've done the changes like we did with this question to the top, then the bottom gets reduced. Okay, so let's look at a question with an equal sign. So 6 over 2x minus 1 equals 4 over x plus 1. So monomial on top of binomials is what we got going on. So our common denominator is going to be both sets of binomials. I have to use both of them. So since they're different, the guy on the bottom right is going to multiply the guy on the top left. The guy on the bottom left is going to multiply the guy on the top right. Okay? So we're going to have 6 times x plus 1 equals 4 times 2x minus 1. And I didn't write the bottom on purpose because the bottom will disappear now. I can cross it off because I've converted the top. Now, we do have to do non-permissibles. What would make the first brackets here on the left equal to 0? Take a positive, okay, opposite sign of the digit, positive 1, over 2. Okay, the number in front of x has to go to the bottom. So 1 over 2, 1/2, and then what makes this guy 0? What plus 1? Negative 1. So NPVs, x cannot be negative 1 and 1/2, positive 1/2. Okay, now we multiply into the brackets, remove brackets. And you literally solve for x like normal. So 6x plus 6 equals 8x minus 4. Bringing the 8x to the left. And taking the 6 to the right. We're going to get negative 2x's equals a negative 10. And we're going to divide up the negative 2. X equals 5. Okay? That concludes lesson or unit 2. So now we've got unit 1 and 2 done. Okay, unit 3. Polynomials. We look at polynomials first. So we have to know the degrees. So you need to know the degree of a graph, a polynomial graph. And remember, the degree is one more than the amount of turning points it has. Always. So one more than the number of turn points. It all works except for, that rule works for everybody except for a constant graph. Constant graphs are the ones where it's a straight horizontal line, there's no pitch to it at all. Okay? So we're going to go through all those degrees. So, degree 0, 1, 2, and 3 is what we're going to look at. Are you going too quick? I'll put it up for a second. Actually, I won't do that. Let's do this instead. Okay. Degree 0. Horizontal. Okay, that's a constant graph. That's a degree 0. Degree 1. Linear. It's either diagonal going up or diagonal going down. Okay, it's a diagonal line. So again, how many turn points does it have? 0 turn points. Degree is 1. So there's one more than the turn points. It all works except for this guy. You can't go by turn points on him because he's horizontal. Okay, degree 2, it's going to be one of those guys. Or he could be way down here, he may not even touch the x-axis. Well, he will eventually, that guy down there. So, degree 2, 1 turn point. So those are quadratics. Okay, so these are our quadratics. Linears are degree 1. And cubics are degree 3. Okay? And that's where you have 2 turn points. Okay? So 2 turn points, degree 3. So that's what's going on with the degrees of the graphs. And it's a numeric response question where it says match the degree to the graph. And you literally have to match the numbers 0, 1, 2, and 3 to which graph. Okay? Any other questions about degrees for graphs? No? Okay. Alrighty. Then we've got degrees of graphs. We need to know how to find x-intercepts. We need to know how to find the y-intercept. So a lot of this, again, is in second trace features. So you always have to use graphing. Your y equals button. Okay, so you're going to be graphing. If it's a projectile, projectiles are always something like this. It's going to be a quadratic. It usually wants to know where it hits the ground, how long does it take, or it wants the max height, or it could say, when did it reach a height of 10 meters? And maybe 10 meters is right here, so you'd want that number and do an intersection. Okay, so if it's at a height of 10 meters, you put that one into y2, if it's a y number. Okay, remember, if it's a y number, you go y2. But the number to y2 is going to come straight across, and then you do an intercept. Okay, if you want the y-intercept, you know the value of x. The y-intercepts on the y-axis is 0. So second trace, number 1, value of x is 0, enter. That gives you the y-intercept. Okay, if it's asking you to compare graphs, so it's going to ask you to compare different graphs. And they're going to give you the equations only. So they're going to say, you have the x-intercepts of -4, -5, and 2, and a y-intercept of +7. Which equation matches that? Well, if it's A, B, C, D, you literally put it in your calculator and figure it out. So they're going to show you ones like this, though. They're going to have fx equals x plus 4, x plus 5, x minus 2, whatever. Okay, they're going to have it set up where you put them with the brackets. Use all the brackets. Type exactly what you see. If you see fx on the left, scribble it out. It just means y. Okay, it's another way of saying y equals. Okay, if you don't like fx, just put y. Okay, that's all it means. So you would literally type this into your equation, see if you get those x-intercepts, see if you get the y-intercept of the 7. If you don't, go to the next one, graph it, and see if you get that one. When they're in brackets, how can you tell natural x-intercepts? Remember how to do that? It's the same as non-permissibles. So take them out as opposite. This guy, -4. This guy, -5. This guy, +2. Okay, it's the same thing as finding non-permissibles. That's how you find the x-intercepts, if it's in factored form. Okay? Alright, so you're going to see questions like that. That's all about polynomials. Okay? So they're going to give you an equation, problem solving, talk about a projectile. You're going to get a cubic regression for sure. It's going to give you a list of values. So if you've got a list of values, the numbers, watch the sequence of the numbers. They don't go all in order. They're going to go maybe 15 to 30, but they might skip number 22. And then the question's going to ask you to find the y value when x is 22. So that's just a second trace, number 1, value of x is 22, find the y number. But you have to watch when you put your numbers in. Because if you've got numbers like numbers 1 to 10, it's easy to go 1 through 10. But if they skip the number 7 and just go 1, 2, 3, 4, 5, 6, 8, 9, 10, and you don't realize that they skipped the number 7 on purpose, this has happened on a diploma. They've done this. I think it's sketchy and rude, but they've made the numbers in here not be sequential on purpose so that they can ask you for a missing number in there somewhere. Okay, so be careful with your tables of values. Okay, it's on the cubic. All right, for being here, I'll give you that hint. All right, so that's all there is to do with all of your cubics and your quadratics and your linears, okay? Then we do sinusoidals. So sinusoidals is this equation. A sine bx plus c plus d. If you know what all of those do, and if you can follow the poster, hopefully you understand the poster and you know the poster. Those are the most important things on there. The A, think of it this way, is radius of a tire. Amplitude, radius of a tire. There's questions where it's going to say, what's the diameter of this water wheel? No wonder. All you got to do is double the A value. Take 8 and times it by 2. That's all you're doing. Okay? It wants to know if you understand which one of these numbers is the one that you times by 2. Because guess what A, B, C, D are? This times by 2, this times by 2, this times by 2, and this times by 2. So you have to know which one to multiply by 2. Okay? They might straight up give you an equation and say, what's your amplitude? Exactly. And you have to know which one, A, B, C, D, which one's your amplitude. They might give you an equation and straight up say, what's the period? You have to know to go 2 pi divided by period. Okay? They're going to give you, I gave you straight up graphs, like we did those graph analysis and those equation analysis. Same types of questions. You guys should breeze through these. Okay? Honestly, I think you'll do fine. What if I want the max? What do you do to find the max or the min? Who goes first? It's always D and then A. So it's da, 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 da. Think of da, da. Okay, right? So it's D and A, D and A. To find the max, you add them, find the min, subtract them. Okay? And that's when you give them the equation. I literally gave equations where I said, okay, here you go. Y equals 32 sine 4x plus 1 minus 7. And said, what's your minimum point? Well, it's that guy, subtract that guy, negative 39. What's your maximum value? This guy plus this guy. Okay, so straight up find it from the equation. And then I gave you straight up find it from the graph. Okay? I also gave you a sinusoidal regression. So there's a sinusoidal table of values, and it tells you the sinusoidal, and it gives the window. Okay? And it's going to ask you for one of the numbers. It might say, what is the amplitude of the function you got? What is the period of the function you got? Remember, you get the b value when you get an equation. You don't get the period, right? So you have to remember what to do with that b value. Okay? It's all about analyzing the equation or analyzing a graph. And I think you guys nailed that. Okay? So let me just pick a couple questions, okay? So let's put this away. And I'm going to grab some questions here. So let's go into, come on. It's slow today. Okay, I'm only going to show you ones that you don't have. So, yeah, straight up questions like this. And you'll have questions like that. Okay, so see where it's saying the zeros are this, no y-intercept of this, which equation? Literally plug it in. Okay? Okay, these ones, I gave you a sinusoidal and I asked for your average annual temperature. What's your average always? What value, A, B, C, or D? Who's the average? Who's the midline? D. Whenever it wants average, it wants D. Okay? Gave you an equation, a graph. Straight up ask for the B value. Aha! Can you get the B value from looking at the graph? No, you have to find the period, and then take 2 pi divided by period to get the B. Okay?
So it's always the line after 0 and then go down. Right? Like it can start before, but it's not at that point. It's when you have your y-axis.
Yeah. Yeah. Start at the Y. Yeah, start at the Y. Yeah, always start at the y-axis. So on this side, start here, and then it goes up to here. Okay? So questions like, here's another polynomial, here's some things, which ones are true or false? Okay, statements about them. Here's a straight up simplify. Okay, what can you math bracket out of that? You would take 81 divided by 36 and literally math bracket. And then you subtract your s's. Okay, so there'd be no s on the bottom. So straight up little questions like these. Sinusoidal, here's your equations. Which one matches the information? Okay, you have to know what your maxes and your mins are. And how to reverse it to go into an equation. Then there's graphs. You have to say what would do the change. Yeah. Yeah. And there's straight up questions like these guys. So here's a Ferris wheel. Where's this one? Okay. If it's asking for how many revolutions in an hour, what am I asking you for? Or sorry, how many revolutions? I'm asking for the period. So how long does it take for a revolution? That would be the period. That's what we're looking for.